Okay, so at the end of the last video, we were talking about particles and their antiparticles, and I had said to you that there are way more particles than this. We now know that there are tons and tons of particles. There's a whole field called particle physics that you could do your PhD in. Like, you could just concentrate on it. So there's many, many more that you haven't encountered yet. And if you're bored and have some time on your hands, you might want to Google particle physics and look at all the different particles. For right now, so we have the electron, like all of these, but there's like muons and hadrons and a whole ton of others. So what we're going to look at today is just the different categories of these particles. So particle physics categories. And these go to those 3 multiple choice questions that we skipped on the first page, the last 3 in the second column. So particle physics categories, so they're divided into 2 main categories. The first category is called bosons. And bosons are considered carriers of the fundamental forces. We believe there are, you have these notes, so why am I doing this? We believe that there are 4 fundamental forces. We believe there's the electromagnetic force, the force of gravity, the strong nuclear force, and the weak nuclear force. So we think that there are these particles, we're going to say, that are what bring about those 4 forces. They don't obey Pauli exclusion principle, and they don't have any mass. So in this category, you will find the photon, which is what we think is creating the electromagnetic force, the gauge boson, the W vector boson, and we think they're for the weak nuclear force, the gluons, which we think are for the strong nuclear force, and the graviton, for the gravitational force. And that's the one that the Big Hadron Collider was built for in Europe. They were trying to find the subatomic particle that was responsible for the force of gravity. Stay tuned. This field is nowhere near done yet. The second category are fermions. I always have to look to see where I put the I. These guys have mass. Okay, and the fermions are divided into 2 main sections, and then 1 subdivided again. They're the leptons, and these ones are tiny little, very small mass. So the electrons and the neutrinos go in here. We believe that these cannot be broken down any further. I say we believe because we also believed at one point that the atom couldn't be broken down any further. So, you know, we're not sure. But they are the small, very, very small masses. We believe they do not interact via the strong nuclear force, but do with the weak nuclear force. They include the electron and neutrino, which you would have already met, but also things like the muon, a tau, and of course the respective antiparticles. Also in this category are the hadrons. So they are larger mass, and they interact through the strong nuclear force. Okay? They have 2 subcategories, the baryons and the mesons. And I should write up here. So these are the electrons and the neutrino. Okay, so the baryons are the group with the largest mass. And the mesons are intermediate mass. The baryons are where we find both the protons and the neutrons. Okay, so these are protons and neutrons. There are others also in here, such as the hyperon, the lambda, the sigma. And then the mesons are the intermediate masses, and they include the pion, the kaon, etc. We believe that these can be broken down. Okay? Actually, we're quite sure of it. I shouldn't even say believe. Okay, so baryon, the hadrons can be broken down. These are made up of an even smaller subatomic particle called a quark, which you may or may not have heard of. Now, a quark is like a lepton in the sense that we think they can't be broken down any further. For those of you that ever listen to CBC, there's a show on Saturday called Quirks and Quarks. And it comes, I don't know which came first. I suspect the show was named probably around when this was discovered. Quarks have been in discussion for about 30 years now. Been in, like, that people have begun to say, to believe it. They were probably in discussion earlier than that, but people weren't buying it. We do believe that they are true elementary particles, just like the leptons. There are 6 flavors of quarks. So we don't say 6 subcategories, we say 6 flavors. And they are the up quark, the down quark, the strange quark, the charmed quark, the bottom quark, and the top quark. They would each have an elementary charge of like a third of a. They would each have a charge of like a third of an elementary charge, or 2/3, or a half, or negative 2/3, or negative 1/2, so that when you add them together, you would end up getting like a proton or a neutron, like with the combined charges. And of course, there are also antiquarks. Each quark has a color. The colors are red, blue, and green. A proton is made up of, 2 up quarks and 1 down one. And there's a page in your textbook that actually has the charges of the quarks. Let me just see if I can find it here. How much time do I have? We still have a couple of minutes. All right. Yeah, I should have planned this ahead, but I didn't. So a down quark has a negative 1/3 elementary charge, and an up quark has positive 2/3. So there's 2 up quarks, so 2 times 2 positive 2/3. And the down quark is negative 1/3. And so when you add these together, 4/3 minus 1/3, lo and behold, you get 1e. A neutron, we believe, is made up of 1 up quark and 2 down. So this would be positive 2/3 plus 2 negative 1/3, which would give you 0 elementary charge. Okay, so particle physics is a really, really cool area, and if you're liking physics and thinking, I want to know more, taking a course on particle physics would be pretty cool. The one last thing before we move into the next unit is I want to just for a minute talk to you about, write the second word first, superstring. Superstring theory. Now, some of you in grade 12 physics would have done your project on it. Really, it goes back to the fact that the quantum mechanics breaks down at speeds close to the speed of light. And so people are like, there needs to be some theory that can put this all together. And so they come up with what's called the superstring theory. And so they believe, now to explain it, you have to realize that there's more than 4 dimensions. There might be 12. Or maybe even as many as 21. And it's hard to understand that, like, how can it be? How come we can't see it? The best way, so they think that like all of matter is made up of really strings if you could look tiny enough. And those strings are in all different dimensions. Think about standing at the edge of the ocean and looking out to sea, and a ship's coming in, and you just see the tiny little dot because it's so far away. But then as it gets closer, you can see that dot actually has some height. And closer still, it has some width. And as it gets closer still, you can see its depth. So one of the things behind the superstring theory is we can't see all the dimensions. We're too